Alright, today I shall be teaching physics on this channel. Remember that I told you that on this channel I shall be teaching mathematics, physics and chemistry. Is that understood? Okay, so today we shall be dealing with what? Units and measurement. Every profession deals with measurement. A carpenter does his work with measurement, whether he's conscious of it or he's not conscious of it. He measures the wood, he measures everything he does. A mechanic in his workshop should know that all spanners are measured. A nut cannot be worked or cannot be loosed by a spanner, which is 10.5, when the knot is 10, that is size 10. It is totally wrong. It will not go. Alright, so every profession, whether mechanic, a carpenter, even a farmer, does measurement. Okay, you can't escape measurement as long as life is concerned. So physics treats measurement as something very, very crucial. And what I want to discuss with you on this channel today is like the summary of everything in physics. It is quite the simplest and the most basic, yet it is the most crucial aspect of physics. You can easily ignore this part in physics, but I assure you, when you take it seriously, you will live to appreciate it as long as physics is concerned. So just as periodic table is like the summary of everything in inorganic chemistry, this topic is also like the summary of everything in physics. So watch me as we progress. So under unit and measurement, the major thing I want us to hit directly is what we call quantity. What we call what? Quantity. When we say quantity, quantity can be anything at all. Quantity can be things you can touch. It can be things you cannot touch. Quantities can be things you can see. It can also be things you cannot see. So quantity is anything at all. Is literally anything. So whatever you can mention, whatever you can think about, is classified as quantity in physics. Meanwhile, quantity are of two basic categories in physics. So there is something called fundamental quantity and there's something called derived quantity. Fundamental quantity, as the name implies, it is fundamental. Fundamental means basic. Fundamental means very important or the most important. When I say the fundamental reason I am here, it means the main reason, the basic reason, the real reason. Is that understood? So fundamental means important, right? So there is something called important quantity. So this kind of quantity can be defined as the quantity through which all other quantity depend, or is a quantity by which all other quantity depend for their derivation. So can we then define for it now? We can say fundamental quantity are the basic quantity by which almost all other quantity depend for their derivation. That is, they stand on their own. You are the one to depend on them. They don't depend on you. Is that understood? Take for example, in the family you have parents and you have children. The children depend on the parent. The parent does not depend on the children. Although at old age, the reverse may become the case. But on a normal ground, the parent does not depend on the children. They stand on their own, but the children depend on the parent. So we can say the parent are the fundamental people in the family. Am I understood? So when we talk about parental point, we also have what we call fundamental unit. Fundamental unit. The definition are quite the same. Fundamental units are the basic unit upon which almost all other units depend for their derivation. So fundamental quantity is what brings about fundamental unit. Fundamental unit is a unit of fundamental quantity. Am I understood? Okay, moving forward, we will have something like this. We will have length, we will have time, and we will have what? Mass. So the length, the time, the mass are the fundamental what? Quantities. I can say fundamental quantity and their units. Alright. So, example of fundamental quantity, we have length, we have time, and we have mass. There are other fundamental quantities also, but these are the most crucial examples of fundamental quantity. Take for example, as me, you are in a class and the whole students in the class are intelligent students. Do you know that when you observe well, you are still going to observe someone that are more intelligent compared to others? Okay, so among all the fundamental quantity we have in physics, these are still the most crucial and they are at the top. Alright, so we have another one called temperature. Okay, you have another one called amount of substance. It's understood. So these are, in fact, we have another one called electricity. That is current, sorry. This is current. Let me wipe it. Current. Okay. Now, what is the unit of length? No, length uses L, isn't it? That is L, right? Unit of length is what? Is meter. That is what? M. That is unit abbreviation. We have M. Please look at this. In physics, or in life, or in the realm of measurement, we have meter. Measurement can be done in meter, it can be done in kilometer, it can be done in millimeter, it can be done in milliliter, it can be done in several other units, but the unit recommended, the SI, which is system data unit of length, is nothing but what? Meter. So in physics, we don't use milliliter, we don't measure in kilometer, we don't measure in centimeter, we don't measure in millimeter, we measure in what? In meter. Take note of it. So whenever we're going to go deep into it, we saw that even when questions are given to us in centimeter, we have to convert them to what? To meter. That is how it goes. So, and we use M as the unit for what? For length. A unit abbreviation for length. as long as you are saying this throughout the world of physics, there is no other quantity that have its unit as m other than length. That means length is the only quantity that uses m as its unit. That is why you should pay close attention. So throughout physics, you will never see any other quantity that uses m as what? As length. It's no longer, it's not possible. All right. So that for time is what? We use t for time. All right. We use t for what? For time. Sorry. That will confuse you. Now, the unit for time is what? Is second. Abbreviation is SEC. In time, we have second, we have minute, and we have what? Hour. Between second, minute, and hour, we don't use hour, we don't use minute, we use what? Second. That is the basic. Second is the basic. So throughout your physics, you are going to observe that the only unit that has second or that is second is nothing but what? Time. So time is the only quantity that has its unit as second. So in the case of mass is measured in what? In kilogram. It's measured in what? In kilogram. That is kg. We also have other units like kilogram. You also have other units like gram. In physics, we don't measure in gram. We measure in what? In kilogram. Kilogram is the basic unit. All right. If it is the SI unit of mass, and throughout you will not see any quantity having kilogram as its unit again. So having understood this, it will make it very easy for you to understand physics as you progress from SS1 to SS2, SS3. You have already known all of these things, so moving forward will no longer be an issue for you. Okay? Temperature is measured in Kelvin. In what? In Kelvin. Amount of something in what? In mole. Current is measured in what? In ampere. That is A. It's understood. Remember that we use T for time, M for mass, or this one may confuse you, so let me just clear it. Alright, so these are the fundamental quantities. As you can see them like this, they don't depend on any quantity or any unit for their derivation. They stand on their own. They are formed by themselves. That is why they call them fundamental quantity. It's understood? That's why they call them fundamental quantity. So in our next lesson, we shall be discussing derived what? Quantity. Derived quantity. And we are going to see the differences. It's understood? Meanwhile, if you find this helpful, I want you to like, I want you to comment, I want you to share. Your questions, your observations are all welcome. Is that understood? So thank you for your attention, okay? God bless you.